So in last session, we seen the binary search algorithm. Now we'll see an example for binary search. Okay, so already we discussed when we having the binary search, the element must be in order, either ascending order or either descending order. So we need to check. What we need to check? The list of elements must be either in ascending order or descending order. Now, for example, for my example, these are the list of elements. Now these elements are in the order, yes, in the ascending order. Assume that we have an element a 13 before 12. Whether these elements are in the order? Definitely not. So to make these elements in the order, we need to use the sorting methods like insertion sort, selection sort, bubble sort, merge sort. So these are the different sorting algorithms to sort the elements in a order. Okay. So now my search element is 8 to perform the binary search. First arrange these elements in the array, okay, with the index numbers. Now 0, 1, 2, 3, 4, 5, 6, 7, 8. Now what is my search element? Search element is S element is what here? S element is the 8. So now this element we are searching into the list is present or not. Which element 8 is present or not, we need to search. If it is present, then we need to display the particular index number of that element. Now, so what is the first step in the binary search? Read the search element from the user. What is the search element now? Search element is the 8. After that, what we have to do? We need to find the mid element to this list of elements. So what is the formula for mid? Mid equal to low plus high by 2. Okay, high by 2. What is the low value? Low is nothing but index 0. High is nothing but index number 8. So here low equal to what? 0 plus 8 by 2. Nothing but index number, we will get the 4. Now this 4 will act as a mid element for this list. Okay, so now with this mid element, we are going to compare the search element with 8. Now 3, 5, 8, 13, 12, 18, 20, 25, 30. Now we are going to be compare. Now what will happen? Whenever you perform the mid element, the list of elements are going to be divided into subparts. Okay, one is the right sublist, another one is the left sublist. What is left sublist? When the elements, the search element, if the search element is less than the middle element, then we move to the left sublist. When search element is greater than the middle element, then we move to the right sublist. So now this is the mid. So in binary search algorithm, the step number 3, what we have to do after calculating the mid? So with step number 3, now compare search element with mid element. Okay, if both are matched, then display the mid element, nothing but mid index number. Suppose if it is not matched, then we need to perform whether mid is smaller or greater to the search element. According to that, we need to go for the left sublist or we need to go for the right sublist. Now compare the search element with the mid element. What is the search element here? 12. What is the 8? What is the mid element here? 12. So 8 is equal to 12. Is 8 equal to 12? No, definitely not. It is false. Then what you have to do? Now, if it is matched, it does not match with a mid element, there are two possibilities. One is mid is greater to the S element. Another one is the mid is lesser to the S element. Now S element is nothing but search element. What is the mid value here? Mid value is mid element equal to what? 12. Okay, is greater than 8. Means when mid is greater than the S element, we move to the left sublist. Okay, when mid is lesser than the S element, then we move to the right sublist. Okay, we having two possibilities. Mid is greater, SL is greater to mid, or SL is greater lesser to mid. So according to those possibilities, we have to take either left sublist or whether right sublist. Now in this case, where we have to move, 12 is greater than 8, means 12 mid is greater than the S element, means we move to the where? We move to the left sublist element. We move to the left sublist. Now take the left sublist. So only take these elements from here to here. Don't consider these elements from here to here. So take only 3, 5, 8 and 13 along with index numbers. What are the index numbers of 3 here? 0, 1, 2 and 3. After taking the left sublist, what we have to do? Again, we need to calculate the mid element for this sublist. So again, how we need to calculate? Same formula. We need to use the same formula, mid equal to low plus high by 2. What is the low value? Low is nothing but always it is a first index number. High is nothing but always last index number of that list. What is here? High is nothing but 3. Means 0 plus 3 by 2. It is nothing but 1.5. Already we discussed in the last session. So always the index numbers are represented by the integers but not with floating point numbers. So now we got the result as the floating point numbers. So what you have to consider? We need to consider only integer part but not the floating point. So here, what is the integer part here? 1. Now we need to take this as the mid element. Okay, this as a mid element. Take the left sublist again. 3, 5, 8 and 13. It is 0, 1, 2, 3. Now this is the mid. With mid again what we have to do here? We need to compare. We need to compare the element. What is the element here? Such element is 8. Again compare the mid element. It is 8. Again already I said when we calculate for mid, again the list is going to be divided into two parts. One is the left sublist, another one is the right sublist. Here again what will happen? These three will act as a left sublist. This from remaining elements will act as a right sublist. So 8 and 13 will act as a right sublist. Now in this case, mid element equal to 5 and search element equal to 8. So mid 5 is lesser than the 8. Okay, 5 is less than the 8. Mid element is less than the search element. Mid element is the less than the search element. Then move to where? We move to the right. So now search element is mid element is less than the 8. Mid element is less than the 8. Where you have to move here? We need to move to the right sublist. Now take only right sublist. Okay, what are the right sublist here? 8 and 13. What are the index numbers of 8 and 13? Index numbers are 2 and 3. Again we need to calculate where up to where we have to calculate the mid. So if we having the more than one element in the list, then we need to calculate the mid. So up to that we need to calculate the mid here. Mid equal to again what here? Low plus high by 2. What is the low value here? Low is 2, high equal to what? 3. Again 2 plus 3 by 2. Now 2.5. So we'll get the result as the 2.5. 5 by 2 nothing but 2.5. Again what we have to consider here? Only integer part we need to consider now. So this 8 will act as a mid element for this list. Again what we have to do? We need to compare 8 and 13. So here it is 2, it is 3. Now compare the search element. Search element is what here? Search element is the 8. So now 8 is equal to 8. Yes, it is true. Now what will happen? So here similarly we are going to display the message as the element found location in the 2. Now